Okay, quick review of the Heaviside function, a couple of important integrals. And you did a pretty good job remembering what the Heaviside function was. You actually remembered it. It was vague at first, and then you got more specific, and you finally, yeah, okay, it's 0 up to here. Okay? I didn't have to prompt you much. I just had to say, can you be more specific, and you were. Okay, very good. H of x is this, right? 0 up to x equals 0, and then it's 1 from there on. And the Laplace transform, of course, you got to remember what the Laplace transform is, but there it is, right? So that's just going to be integral from 0 to infinity of this. And from 0 to infinity, h of t is 1, right? So you just get this integral, and that's a trivially simple integral. Not totally trivial, but really very straightforward integral, very easy integral. You get this, okay? And then h of t minus alpha. What's h of t minus alpha? Well, you immediately said it's just h of t shifted alpha units to the right. Again, very good, okay? So I suggest you make a picture of that and then write out what the integral is. Now, your picture got screwed up. So, you know, you had alpha going this way or something, you know, but you knew. You just didn't, when you got to writing it down or drawing it, yeah, it only gave you a minute or two. You didn't quite get that right, but that's simple enough, right? Which kind of guides you to this. This has to equal this. Because you're integrating e to the negative ts times your h of t minus alpha from 0 to infinity. H of t minus alpha is equal to 0 up to alpha, and then equal to 1. So I say, okay, what do you do with this integral? And you answered, well, you split it into two integrals. Very good. So here's the first integral. Up to alpha, the h function is 0. Beyond that, it's 1. So the integral from 0 to alpha is just going to give you 0. And the integral from alpha to infinity is just going to be the integral from alpha to infinity to e to the negative ts, right? And that integral is really simple, despite the fact I didn't write my 1 over s when I wrote it out. So I screwed up, but you called me on it and you asked me about that, okay? So if you work out the details, it's clear that you were thinking the details, so you don't need me to do that, and it's a good thing, okay? And I'm really careless. It just, you know, okay. Anyhow, that's what we have, okay? And those are a couple of really important properties of the Heaviside function. Now, and I'm not sure we did this. We might have done this before because I know I was tempted to do it. I don't remember if we actually did. Take an RC circuit or an RLC circuit, okay? And hook up a constant source of EMF with a switch, okay? And close the switch, open the switch. Close the switch, open the switch. Close, open. Okay? So what's your voltage function going to look like? What would a graph of your voltage function look like? Because what we're going to do is we're going to use the Heaviside function to construct that graph. To symbolize that function. Okay? So show me a graph of what the voltage function would look like.